Okay, so we're going to be working on our last day of cross-sectional volumes. So this is the same problem that we did the last time in the notes, except we're going to be doing cross-sections that are perpendicular to the y-axis, okay? Because Friday I recorded the notes, the same equations with it perpendicular to x and now perpendicular to the y, because it goes with your practice problem that asks you to do the same thing. So basically we're using the same functions, the same area bounded by these equations that we worked on the last time. The difference is that our isosceles right triangles are perpendicular to the y-axis. So just to give you an idea, so here's my parabola, here's my linear function, okay? This is the point 0, -1. This is the point 2, 3. Now, our cross sections are going to be isosceles right triangles, and it says a leg is in the xy plane. They're perpendicular to the y-axis, which means they're going to look like this. Here's the base, here's my 90, and then here's my isosceles right triangle, like that. Okay? Now, as soon as I see that my cross section is perpendicular to the y-axis, I know I'm using this equation. From a to b, a of y dy. And my area equation, a of y, since it's isosceles, it's going to be 1/2 b squared. So that's the area in terms of the base. Now, the last thing I need to figure out is what is my base. Well, since it's also from here, this is my base, it's going to be the function on right minus the function on left for the length of the base. But it has to be in terms of x equals, okay, because they have to be in terms of y. So that means I'm going to have to solve each one of these for y. So y equals 2x minus 1 is x equals y plus 1 over 2. And the other one, y equals x squared minus 1, ends up being x equals the square root of y plus 1. So you got to solve both of those to get in terms of y, get it as x equals. Which means that my base length is going to be the right one, which is my parabola, minus my linear function. And then plug that into your area equation over here, which means it's going to be 1/2 the square root of y plus 1 minus y plus 1 over 2 squared. Okay? Now we use our equation, we plug in. So basically, since our y values are now going to be our limits, it's from -1 to 3. 1/2 square root of y plus 1 minus y plus 1 over 2 squared dy. So now that I have my function set up, now it's just time for some algebra. So the hardest part about this is going to be foiling all of this out. So once you FOIL all this out, you get the integral from -1 to 3. Remember, you got to FOIL everything, add up like terms, so you get 1/4 y squared plus 3/2 y plus 5 over 4 minus y plus 1 to the 3/2 power dy. Okay? Now, one way of doing this, and probably the easiest way of doing this, is actually splitting it up into two integrals to make it easier. Okay? So that's what I'm going to do. I'm going to split it up with my polynomial in 1, 1/4 y squared plus 3/2 y plus 5 over 4 dy minus the integral from -1 to 3 of y plus 1 to the 3/2 power dy. Because to evaluate this 3/2 power, I'm going to be using U-Substitution, integration by substitution. So polynomial, the antiderivative becomes real easy. You get y cubed over 12 plus 3y squared over 4 plus 5y over 4 from -1 to 3. Okay? Okay. Now on the other one, you got to do U-Substitution, which, I mean, if you practice it enough, should be really easy. This ends up being U is equal to y plus 1 like this. So du equals dy. This ends up being u to the 3/2 power. So add 1 to the power divided by the new power. So you end up getting 2/5. This is minus 2/5 y plus 1 to the 5/2 power from -1 to 3. Okay? Problem we've done a bunch of times. So now we just plug in and go. So here we go. So plug in 3 here, so we get 27 over 12 plus 27 over 4 plus 15 over 4 minus -1 over 12 plus 3/4 minus 5/4 minus, and then this is the second part. You're going to get 2/5 times 4 to the 5/2 minus 0. Okay? Simplify. You're going to get 27 over 12 plus 42 over 4 plus 1 over 12 plus 2 over 4 minus 2/5 times 4 to the 5/2. And the reason I left it, I know 2 over 4 is 1/2, but I have over 4s. Makes my life easier. So I end up with 28 over 12 plus 44 over 4 minus 2/5 times, now 4 to the 5/2. That's the same thing as 4 to the 1/2 to the 5th power. And 4 to the 1/2 power is 2 to the 5th is 32. Which ends up being, this ends up being 40 over 3 minus 64 over 5, which ends up being 8 over 15, which is our volume. So this one is pretty algebra heavy. Matter of fact, when I originally worked this out, I made a small algebra mistake. So you got to be very careful. Where you're going to make your mistakes on this one is going to be in the algebra. So be very aware of that. Okay? And if you compare this to last week, it actually has the exact same volume. And that's one of the questions that I ask you in your practice. Does it have the same volume, and why?